Hi, I'm Andrew Armstrong and welcome to the back office. Today we're going to solder or practice soldering some surface mount components using one of these boards. That's why I've got a bit of white paper today so we can get a bit more contrast here. And this is basically a training kit. You might have seen my unboxing video on bagging, I suppose, of this. You can get them on eBay. I'll try to post a link down below to where I got it from, but there's many vendors of these, and the idea of the kit I think is just to sort of teach you how to solder. And I've sort of had a really close look on the at the circuit under the light, and there's not much there, to be honest with you. It's basically the resistors are all wired in series, as are the diodes, and there's an LED and it goes straight to the voltage plus and minus. You'll get the LED to glow. And there's a couple of footprints. They give you like some NPN transistors and some op amps and things, so you can just practice putting them down, but they're not in circuit. Maybe we'll be able to wire them up somehow with some Kynar later. I mean, that could be a bit of fun. So I'm just going to sort of crack on really, and just sort of tackle this the way I'd normally tackle it. I've just got my soldering iron onto the side. I've got my blob of let's just zoom out a bit, you can actually see what's going on. I've got my blob of stuff, I've got a roll of solder. That's pretty much my setup. So if you're going to do any sort of surface mount, I should think get your tip cleaner, get a tube of flux. I've just got it in a syringe. It's a gel flux, I prefer it that way. And then get your solder, and it's a bit thick to be honest for surface mount. We're going to have a bit of fun and games with that, but it'll be fine. And I was going to show you this. I don't know, I've got ideas on how to do this. I've got two of these boards, so I thought I could do one with just a soldering iron, and then one with heat, with just the hot air blower, because you can use a hot air blower instead of just a soldering iron, and you can use solder paste or solder. So we've got sort of loads of techniques, and I've got a reflow oven. But I don't know if I'm going to be able to show you all of those, certainly not in this video anyway. It'd be a couple of videos we've got to spread this over. But this is some solder paste, and it's kind of gone hard, and it's not my favourite one either, so I'm never going to get that out of the tube. So I'll have to have a little route around, might need to order me up some soldering paste, but it doesn't matter. We'll just sort of crack on with the soldering iron, which is going to be the hardest. And also, of course, we do have the USB soldering iron. I might try that as well. So let's get going with the soldering iron. Just going to clean the tip there. So just to show you, we've got some, we're going to drop in some resistors, I think, and these are the 0805 size package, and you'll see them here when I open them up. So they always come on these strips because these are strips that feed the machines, the pick and place machines. So when you buy them, even when you get them from the catalog companies, RS, CPC, whoever you're ordering it from, Farnell, they'll come like this. So decide how many you want to sort of get out any one time. I'm going to go for, I guess, 6 here. You don't want to sneeze. Now these are all quite large components for surface mount. They definitely go smaller, but they're sort of quite typical of things you can find, and certainly that for a hobbyist, if you're going to design your own things in Eagle or whatever you're using, that's the size I would recommend. 603s, oh, they're okay too. You can just about do those by hand too, but once you get smaller than that though, it's going to be a bit tedious. So my first trick, my technique then. I've got my soldering iron set way too hot. So let's pretend this is like you at home and you've got the sort of cheapo soldering iron set way too hot. So what you do is just sort of tin one pad. So you can see there I've just tinned the one pad. You might just see a little blob on it. You're going to need tweezers, by the way, if you're doing any sort of surface mount. You're not really going to get far without tweezers. And then I've sort of held it with the tweezers and the soldering iron till it just sort of sits on the pad. It's more or less in the right place, and then there you go, just touch it on the other side, and that's it. That's that resistor on. Zoom in a bit. Let's do the next one. In fact, let's do a few. So what I'm going to do is I'm going to go through and just very lightly tin these pads like that. Only do one side or you're going to come a cropper on that. So there you go, that's all of those. So get yourself a little process, you know, how you're doing it. If it's a circuit that you're building yourself though, of course, you're going to be doing it in step-by-step testing each section of your circuit out. So you're going to test the power regulation, you're going to test the clock, you're going to test the thing, test the CPU. But for this, we don't even have to think, we're just sort of chucking these down. Now you can see they're not quite nicely centered. You're always going to have problems getting them nicely centered when you're doing them by hand, but all is not lost, because if you've got a hot air blower, like I do, what you can do is plop everything down like this, and if you want to get it a little bit more picture perfect, you can just apply the hot air blower and they'll all kind of just jump into the right place. Let's get some more. Oh, I almost lost our LED, stuck to my finger there. In fact, I'm going to go for broke and tip out all of the resistors now. Oh, there's one stuck in the pack. Right, let's get this last row done. And you can see it's quick, right? It's pretty quick. Most of your time normally is just spent picking the components, so you don't normally design a PCB with 60 of the same components on them, so this is a rare opportunity for you just to sort of practice technique nice and quickly. So that's the first row there done. Just going to lay down the next one. So just, I'm ever so quick. Some of these are getting a decently thick blob, and some of them are getting a little thin blob. You don't really want it too thick, of course, though. Remember, these are going to use hardly any in manufacture. You could put some upside down. That would be a mistake. I might try desoldering one as well, just to show you how to desolder something. If you're not careful, you'll have them sticking up as well. Sometimes that happens. They'll just stand up on their edge. But that's okay. It's easy corrected. To be honest, if you've got your soldering iron set at a nice temperature, probably a bit cooler than mine. Mine's at 353 degrees. You've got quite a lot of time to work with it. Really, these boards are going to be quite resilient. I don't think you'll ever damage this PCB, for example. It's just way too thick. The spacing between the components is really far. It's not going anywhere. So just take your time with it. Right, 3 more here. Just got to flip them over. So you can see the tweezers I'm using. Get yourself good quality tweezers. Looking to spend, I would say, at least £30 minimum. Right? If you're looking at tweezers that are any less than that, they're not going to do it for you, I'm telling you. And you're going to think surface mount is horrible, but it's not the surface mount per se, it's the equipment. You really need those good quality tweezies. There we go, that's that last one. So as I've done now one side on all of those, all I've got to do now is do the other. So I'm going to do a few with and without flux. So look, here we go. These will be without flux. And it's actually going really well because the board is clean, everything's good. That one could have been a bit better. There we go. So that's without flux. So it all just went on nice. Some of them aren't quite straight, but electrically there's no difference there. So I'm going to do some flux ones now. So I'm just going to run this basically gel down the board. I'm hardly putting any because it's really not necessary anyway. And I'm going to show it to you. Actually, I can't. It just drives me nuts. The board's the wrong way around. It's madness. So I'm going to zoom in on this one. See if I can just about fit everything in. Yes, I can. Hopefully I won't jog the board and it all goes out. So now you can see what it's like with a bit of flux. So actually that's like really worse. No, it's fine. You just got to let if you're using flux though, of course flux won't work unless it's warm, so you can see it flowing. Just if I hold it to the side here, that it does flow ever so nicely. But yeah, that's good too. To flux or not to flux? That is the question. Just change the technique slightly. So you can see there I've had to change the technique. Just hold it on there just ever so slightly longer. Just to let that flux kind of cook a bit, boil up. Yeah, it's good. Smells like a burning pine forest. So that's the 0805s done. What else have we got? So we do have a bunch of these fatter resistors here. I think that strips for there. So we've got these horrible 0603s. And I'm not even going to get them out of the pack, the 0603s, just yet, because I'm going to do the same tinning trick. And you can see they're that much closer. I mean, this is like a masochist's set, isn't it? And I'm going to just put flux on the right hand side ones as well, and I've left the left hand side ones without, so we can see if there's any difference there in the technique. So we're going to do the same thing, just tinning the one side. You can see the size of the solder now. It's making a nice little ball. I guess these PCBs are slightly tin, so maybe you could just get away with trying to solder into the tin. You can see the balls are actually, I can't really get much smaller than that, so they do protrude a little bit off the board. If I tilt the board there, you can see it. You can definitely feel them with your finger. So bear that in mind now. We're going to have a bit of fun now when we get out these ones. So let's just peel them back. But if you get used to surface mount, it's really useful because you can see how many components you can store in a really small area. So they're really expensive from places like Farnell, but if you go on eBay, you can get resistor books pretty cheap. They're a little bit like, there we go. So you can see them already trying to jump out. That's them. Now you have to start being a bit more careful. They're not quite like the smallest dust ones yet, but you're starting to get close now. That's all of them. Let's get back zoomed in. I'm just going to be picking them up off the side. I know you might not be able to see them all. Just be careful, even when you're brushing them like this, they'll just sort of, if they catch a snag, you'll flick them across the desk and that's it, they're gone. Oh, I forgot my thread now, what I was talking about. Doesn't matter, it'll come back to me. Right, so there's one. There's two. So you've got to be a tiny bit more careful with these as well when you're working the other side, because they're that small. You can actually heat sometimes both sides at the same time. Look, I've got one stuck to my bloody finger tip here. There we go. Yeah, so as I was saying, you can buy books of all these components and they're pretty cheap on places like eBay, and they'll give you sort of, you know, every value you want in, there you go, dropped one, in whatever multiple you want, you know, tens, thousands, hundreds, whatever. It's good though, look, there you go, they're all going in, it's not really a problem. My only problem is most of them landed upside down, so I could I could just solder them in upside down, and I'm pretty sure you'd forgive me for that, because electrically again it's the same. Now they do have writing on them, they do have the values printed on them, so technically some of these are upside down in another way. But I don't think on the camera you're not going to be able to read the numbers, so I'm going to get away with that. I could pretend I've taken the care and put them all in the right way around. Doesn't make any difference on these, but for obviously diodes it does. But diodes, see, I've got one stuck on the end. Diodes, you can correct me on this, and it does sound a bit bonkers. I've always used diode packages that are quite large. Now I'm not saying diodes don't come in smaller packages, because clearly that's madness. They must do. I'm sure you can get a 0603 diode, but you can certainly get an LED, so it must, you know, therefore you can, but I wonder why I don't see them that much. It's just maybe because they're so pain in the arse, you might as well just design a bigger one. So most of my time here is spent trying to flip these bloody things. So there you go, just that one on the top, just by that R40. Now we're on R40, and this is the side with no flux, so we're going to see if there's any real difference there. There's a difference in the shape. It's definitely made a different shape, the little ball, but I think the biggest difference is without the flux, I can feel the component isn't sticking, because the flux is acting as a slightly sticky thing, and we're not getting that benefit at the moment, but that's okay. God, we're almost there now, guys. I think I wonder how many of you have managed to stay with me for this quarter of an hour, however long we've been at it so far. But the reward is almost there, because of course I think you've seen enough placement of resistors, and I think you're itching to see a few diodes, aren't you? Itching to see a few diodes. But the real magic, of course, is in the SOP16 and the SOT23 packages. That's the real deal when you start getting into the integrated circuits and transistors. And we're almost on that. In fact, how about we, you and me at home, agree on something? Should we just do a little sneaky social contract between you and I, and we're going to just maybe move on to some of the other more exotic components, and then revisit these diodes and resistors afterwards, because just as a bit of a break. I'm getting a bit bored of these, but I do want to finish this board, and I'm going to finish the board. And I can hear I'm going, well, why don't you just do the other things and just not bother with those diodes and resistors? Well, if we don't bother with them, we're not going to be able to put power through this board and see what amazing reward we'll get for all this work. Right, so that's it. Whew. So we've done one side. Right hand side again, all flux. The left hand side is not, is sans flux. So let's just get on there. Bang. Good. Again, that's good, that's good. Same technique applies actually, just wait for that flux to, you'll see it. It'll just give you the slightest hint that it's sizzling. It's sizzling right now. Bit of a blob on that last one, but again, electrically should be alright. Although we're going to be able to test it, aren't we, when we put some power through. So if I was to make a recommendation, I'm kind of, I don't know now. I think Flux might be winning on the, definitely on the 805s. No, Flux is better. Just, you got to use a bit of Flux. Saves you going around doing stuff like this and just sort of heating them a little bit longer. Yeah, that's good. That's good. Right. So what should we do? I don't want to do any more resistors. We have some diodes with a plus and a minus. So that's interesting. We could put some right there, but let's leave the diodes off. How about, as a little treat, we do... Oh, hang on a minute. We're going to do U1, which is this SOP16, but I just noticed it hasn't, in the packet, got the chip that goes in the other footprint, and neither does the other one. I feel shortchanged now. We don't have something to go into this SOP28, although I probably have something on the shelf. We can probably find something for that. Anyway, the SOP16, that's fine. That is going to be a really a nice little easy one, because you see the pin spacing on them is that much wider than those, so we're not going to have a problem with that. There's all these little quad packs and stuff are always fun too. It's a shame this board doesn't have any of those, but we'll cover them in another video, no doubt. They're still doable at home. So these are pretty easy. What I would advise, again, same technique, get a tack solder somewhere, just one of these edge pins, and I'm going to use this one because it's the closest to my right hand, which is the hand that holds the soldering iron, and I do apologise if my fingers are in the way. I'm just positioning it up. I'll try it with the tweezers. Maybe that's I can show you a bit better, even though it's more awkward. If you're doing it at home, just use your fingers. Just line it up while heating this pad, and whilst you're still applying heat, you can kind of drive it around the board till you're happy with it. So I'm just going to now study that. Yeah, that's pretty good. Could be slightly higher. You could see it could go up slightly, but that's well within tolerance for this. That's fine. So then just take an opposite pad and then apply your solder. So now that thing is locked in. So we're going to try two techniques. So the first technique on the left hand side, we're just going to apply the solder pin by pin. Okay. Again, we didn't flux this, but we probably should have, but it doesn't matter. I mean, this solder does have a little bit of flux in it anyway. Okay, so that's that one done. The other way is quite fun, is where you just drag the tip of the soldering iron along the pin. So if you put a decent sort of little blob on the end, and this one really does work best with flux, you can just drag the soldering iron like that, and you can just see there each pin is actually soldered nicely. And look, if I just repeat the exercise, just got a bridge on that one, clean that one off, a bit too much solder, and I can even do it again on the other side here, look, to touch them up. Done. How easy was that? Look, I'm going to take the effort to try try to get the camera to convince the camera to focus on it to show you, but yeah, there you go. Done. You see, don't be afraid of those. They are no problem. How about some transistors? We've got 6 of those to put down. I'm looking at the diodes now, and I'm really worried because I don't know what way round things are. So when you have the long leg positive, when it comes to diodes, is the mark on the positive or the negative? I think it's on the positive, and I could put them all down, and I might put them down wrong. In fact, sorry, let me just adjust myself here so you can't see these components I've just sort of unleashed. But there you are. There's the little transistors sitting there. Yeah, if I put them all down wrong, at least we get to lift them and try again. So I'm going to go with Q1 by putting the blob on that middle bit, which I don't really know if that's what that is, if it's the base or the emitter or the collector. It's one of them anyway. You'll have to consult the data sheet. So these have all landed on their back. They love it. If there's a way round that a transistor is going to land in this package, it's on legs akimbo. So let's just touch that one up there. Bang. So you could see how critical it is to have the tweezers there. You're going to have a lot of fun and games trying to get that into position by hand. Right, that was that one. Now I've got some shitty tweezers somewhere. Here they are. Now I'm going to show you what it's like to use shitty tweezers, and let's see if it might work. I'm going to do exactly the same way. So we're going to solder the top bit. Right, shitty tweezers, let's go. I'm already struggling to even squeeze them because they need so much force. So I can't feel the component. So that's the first bit. I'm squeezing them, but I can't feel the component because the pressure on the tweezer is too high. It's fighting me. Okay. Yeah, see, this is what you'll have if you get those horrible cheap tweezers off eBay. I'm finding it nearly impossible. There we go, got it round. I think it's better just to use it just to push the bloody thing along. Right, so let's see. It's soldered in, but soldered in wrong. Well, that's kind of, I just wanted it to be anchored there. I wouldn't want to be using those in my mobile phone. I'm going to put them aside now. I think we've proved the point. Don't use them. If you're doing something sensitive, you're going to just do damage with those. So that was good, doing it on the top. I kind of think maybe doing these right feet, if that's the right way of describing them. The right feet, these pads on the right hand side first, might be actually easier from a structural point of view because it's closer to my right hand. Yeah, so I think that's a good way as well of doing it. They seem to try to centralize a little bit better that way. Yeah, that's working. It's all working, it's all good. So I'm kind of miffed now. They sort of seem to have cheapskated me out of a component. That would have been wonderful to show you as well, because that same trick of dragging the soldering iron along the edge of the chip works for those too. The only difference is you just got to be a little bit, more attentive after you've done it, just to make sure you haven't got a little bridge, because they're going to be really microscopic at that point. Right, let's just get these in. Bang. I think it shows distinct lack of imagination actually in the designers of this board to not have all of these bloody things do something. So by the way, that thing there is a quad channel comparator. So we might be able to do something with some LEDs or something with that. Who knows? Right, the final run now. Let's get this last few resistors in. You can see I haven't done a surface mount thing for ages myself, so this is like a refresher for me. So I'm hoping now that we'll be so good at these last resistors, it's just going to be a blur, practically a blur. And I promise you, you'll be seeing it in real time. No camera trickery. So these are a 106. These are huge. Look at those in comparison. They're like mammoths. The problem is, again, look, I've got to tip them out to use them, and by tipping them out, you're tipping them all upside down. So maybe if I just go for it. There you go. Look, I juggled it a bit, so I guess you got 50-50 chance they'll fall out the wrong way, right way. So yeah, fine, good. Let's get those in, and then my heart will sink, of course, because what did I say about the diodes? Don't know which way around they go. It's strange I haven't used a footprint on the silk screen. You know, that's the drawing on the board, just showing where the line is. I think that would be infinitely more useful for someone having to handmade them. If you're designing your boards in a CAD package, bear that in mind yourself. If you're not going to want to remember which way things go around, just make sure you use the footprint, the appropriate footprint that shows you exactly which way it goes. I mean, that's the point, right? You don't want to have to pay engineers to assemble PCBs. You want to be able to pay people, well, probably kids, I guess, in Far East to assemble it for you. Okay, we're nearly there. These are a lot quicker, aren't they? It's certainly a lot quicker when you don't have to turn them upside down or right-wise them. Do we have a spare? Ka-ching! I think we've got a spare. That's good, that's real good. We're all there. Let's get the other side done. Bang. Bang. This one's really an outlier. Look at this bottom guy. He's hardly he's not with the program. So see what I'm doing there? Did you see that? I was just basically moving the soldering iron back and forth between the two pads till they were molten, and then it kind of jumped into its final destination. So I don't want to do this other resistor, but I feel I don't want to waste it, so I'm going to park it here for now. So he's parked on there, and you'll see this actually sometimes in old computers and things. You'll see like a little hacked on component, a bodge component. Right, I'm just going to go for broke, and I'm going to say the line on the diode is the plus side, and that's the bloody that. And these diodes are in these sort of signal diodes, and they're in a sort of round package, and they've got a really good chance of rolling off the desk, so just going to be a bit careful there. See them rolling like little cylinders of goodness, and they're no different really than the well, you can't see them rolling around, can you? Because I've not shown you. They're basically like the sort of diodes that you get, normal diodes basically, but without the legs, if you know what I mean. The legged ones. These are not the non-legged ones. Boom, little cylinders. And that's the nice thing again about these tweezers. They've got very little hands on the end. You might not just about see them, but they've got little grabby hands. So they don't let things like cylinders slip through there. Ah, it's running away. There we go, got it. That one tried to just escape totally. Now I've got to turn this one. Nice. Did you see that? Did you see that tweezer technique where I twisted? Look at this. Got it? Gonna twist the tweezer right round. There we go. It's the right way around for me now. You don't really see these so much in things anymore. But if you look at an old telly, CRT telly, you'll find some of these old diodes like that. Now that one that was not behaving. So make sure your soldering iron is really heating the junction between the two things. You want to try to heat the pad and the component at the same time for best results. Right, and here's a tiny little LED. You're not going to see this until I really get it out of the pack and show you, but they tend to have a little marking on them, like a notch or a dot, to show you which way round they're supposed to go. But I'm having awful trouble just getting it out of the bloody pack. Don't lose your patience though. Whatever you do, don't lose your patience. There it is. Now I'm pretty much zoomed to the maximum zoom, so the bit to the left here has a tiny green mark, and I'm pretty sure, I can't show you that, but just take my word for it, it's there. So it doesn't even want to leave the tweezers, so I'm just going to put a smear of flux so it'll stick to it. There you go, it's stuck to it. That is a tricky one. That is a very tricky one. So the reason it's tricky, the surface tension on that component is going to make it want to stick to the actual tip of the soldering iron. So you want to solder that and hold it with the tweezer at the same time until it's really cooled down, like that. There you go. Hurrah! We're done. So I guess the only thing left to do is power it up, and maybe to do that, while the soldering iron's on, we'll just hook a couple last bits of wire on here, and those will just be our battery terminals. So we've got a positive here and a negative, and the positive we will leave as red, so we're going to put the green on the negative and the red on the positive. And I'm hoping we've got the diodes the right way around. We're about to find out anyway. So we've got the bench power supply, we're going to turn that on. It's on 4 volts at the minute, which probably is fine. So there's our positive, or our negative rather, and there's our positive hooked up. Moment of truth. Not seeing much. Yeah. Not seeing anything. Did I put the diodes on the wrong way? So you're going to maybe need to do this yourself. And that's debug it. So let's see. We are seeing 5.2 volts there. What do we see here? I'm just going to try to probe at different places. Hang on a minute. What am I up to here? Okay, so we're seeing the full 6 volts there. 5.8. Still, it's not really registering anything as a loss. It's not dropping down. 2.7 volts. 2.8. Very odd. Yeah. So there you go. Fascinating stuff, isn't it? I may or may not have put the LEDs in the wrong way around, or the diodes, but I'm just trying to see the circuit here. I can see for sure the diodes are going like a zigzag, like that, basically. But I can't help feeling I'm seeing definitely a lot drop here. So at this end of this diode you're seeing 3.7 and then you're seeing 1.7. So it's like 2 volts, 3.9. So yeah, I don't know. Let's try flipping them, shall we? Maybe I did cock them up. I don't know what the drop is over a diode though. You do lose something, but I can't remember. So this circuit's actually live. It's still hooked up to the whole meter. I'm going to put that away. Hooked up to the bench power supply. So we're going to try to just take off these components. So that's going to be interesting on diode. So right, so that's flipping it. And because it's now in a horrible state, that's alright. If you've got solder braid, you can use that to actually clean these pads off. I'm just going to zoom in so you can see what I did. So I've got this diode D2 here, so you can see what I'm doing is I'm just sort of moving the soldering iron between the two pads, just moving the tip back and forth, back and forth. Now it's trapped, get off, there we go. But then they're saying the problem you have is that there's already solder now on the pad, so it's not going to sit down. That's why we don't tin both pads when we put these on, because it's just, you got to go back and forth, back and forth, back and forth, back and forth like that. But that's all right. Made it sound like it's a massively big deal. It's not really. I'm going to flip that round. Just going to get those ready. Back and forth, done. And we've got this last guy, this last little LED. I'm trying not to short out the circuit. No, still doesn't go on. Curse it. Curse it to hell. Curse it to Hades. I should have gone online really and just look up the data sheet to see what the marking on a diode is. But let's try one last time. So we're seeing 1.6 volts now, 1.5 volts, 1.4 volts, 1.3 volts, 1.2 volts. Okay, so we're seeing it though. Maybe, I don't know, just what's the input voltage supposed to be? I don't know. My thing is pumping out like 30 volts, and that whole thing's not really doing anything. So I don't know. Interestingly though, it's really quite confusing. Hang on, am I losing my mind? 32 volts. By the time you get here, it's 2.4 volts. Maybe there's just no current in this bloody thing. I mean, the meter's telling me it's using 4 milliamps, so I don't know. Maybe you can't get the bloody thing to go. So let's just turn that last thing right down. I'm going to turn it down to sort of, 3 volts. Current limiter set to maximum, or sorry, minimum, no current limiting. Let's just do some manual probage and probably blow it up. That's fine. Hey, there we go! Hooray! Ooh, it's a bit brighter. Dimmer, brighter. Way too bright. Dimmer, brighter, way too bright. So yeah, I hope that's been of some use to you. It looks like whatever the values of these resistors are, I don't know. They're just eating all the power. I'm not sure who designed this kit and how they intended you to use it, but I can't see there's any way. Nothing's getting through to that LED. So I've got the bench power supply now, just fully 32 volts, nothing. So yeah, I hope that's been of some use to you anyway. Got a little bit rambly towards the end, but I hope we all learnt something together. And that's that marvellous board. Look at it there. Yeah, I think that's quite good value really for the £1 or whatever it is it costs. Let's get rid of those. Yeah, it certainly will have taught you how to do some tricks with it. You can see certainly these transistors and stuff, you could actually use those. They're just NPN transistors. You've got your comparator, you've got your diode, and you've got a few resistors. I'll just tell you the values. I'm just tilting them to this one's a 3483, whatever that means. A 39, I want to say 39C, might be wrong there, and a 116 or a 911, one or the other, who knows. J3Y standard sort of NPN transistors and signal diode. So you could use the parts on this for something, or use some Kynar wire and jumper it and make your own interesting thing. So please like, share, subscribe if you're that way inclined. If you've got any comments or questions, please leave them down below, or if you're on Patreon, leave them as a Patreon message to me, and you'll get super priority. Yeah, but look forward to chatting to you about it. Let me know if you've got one of these and you've gone with it as well, and if you know the mystery of the LED. If there's any way I could make that glow, let me know, but I really don't think there's enough current by the time you get through these resistors. Okay, plug it into the mains perhaps. As ever, thanks for watching.